In this video, I'd like to show you how Microsoft Excel can be an excellent tool to use when you're working with regression, linear regression. So what we see here is some data associated with watching TV in GPA. We can see that for the TV watching and the number of hours per week, it's correlated or it's related to the GPA, and we want to see if there is a relationship. So one of the first things we can do is we can create a scatter plot of this data, seeing if the relationship actually exists. So we're going to go ahead and highlight the data and then insert a chart. And we're going to go ahead and insert a scatter plot. And we can see, well, it kind of does look like there's a relationship here between the number of hours of TV that someone watches and their GPA. We kind of see it declining as you watch more and more TV. I'm going to move this up here. What I'd like to do is to add a trend line to this, or a regression line. So I can right click on one of the points and I can add the trend line just by doing it here. That's one way. You can also use the plus symbol and you can add a trend line. You'll notice that on mine that I have various options that show up. There are different types of regression you can do. I wanted linear regression. But as I look down here in the settings, I'd like to display the equation of that line on my chart. And I'd also like to see the R-squared value because we're going to see that that is important to us. So I'm going to go ahead and close that formatting now. And here's that information that was given me. I'm going to move it up here where I can see it. Now, according to this information, I have here a slope-intercept form of a line. And there's a way that we interpret these. For my slope, it says that for every one increase in my explanatory variable or in my number of hours of TV that I watch, my GPA tends to decrease, the negative there, it's decreasing by about 0.03 per hour. So for every 1 hour in my run or in the explanatory variable, my response is responding according to the slope. It's going down by 0.03. The y-intercept also has a explanation. I can say that if my number of TV hours is 0, so if my explanatory variable is 0, the output I would expect is a 3.38, or I would expect a 3.38 GPA if I watch no TV. We want to be able to interpret those because there should be some meaning associated with them. Now, this R-square is a measure of how strong this relationship is, and we're going to take a look at that here in a minute. Now, one thing that Excel can do for us is that it can give us lots of additional statistics. So I'm going to go to the data and use this data analysis tool. This is a tool that sometimes has to be added into Microsoft Excel. So if you don't have it, you want to go under File and you want to go to the options. And we're doing an add-in. So you go to the add-ins. And you'll see this analysis tool pack. That's what we're looking for. But you come down here to manage Excel add-ins and you can go. And you'll see that I have ticked the boxes for analysis tool pack and analysis tool pack VBA. Those are the ones that allow me to see this data analysis tool. So make sure you've got those boxes checked off, and then you should be able to see this tool in data. So I want to use this data analysis tool, and it should give me a pop-up window. And in this pop-up window, there are lots of tools here I can use for data analysis. What I would like to do is to do some regression. So we're going to do regression. And just click OK. And this is going to be a wizard that's going to lead us through what's needed by Excel to do this analysis. So my Y range, that's my output or my response, that was GPA. I can put that into my wizard by clicking on this box next to the input and just coming over here and clicking and dragging through the response, GPA. Now I chose to put the label in there as well. And I just need to make sure to tick this box that says labels if I'm going to include that label. If I don't include it, I just won't check off that box. So my X range, similarly, I'm going to include the label since I did it with the Y's, and I want these to correspond. So there's my X variables. And we should notice that both of these are getting 11 rows, 1 through 11. So they need to correspond or it's not going to work. Now there are other options here for different types of statistics. We're not going to deal with those. One thing I do like to do is an output range. I can tell it where I want to put it in my workbook. So I'm going to tick this box again and just give it a place. So I'm just going to come up here next to my graph and I'm going to say put the output there. Some other things we'd like, I want to actually see the residuals. So we'll talk about that here in a minute. And the residual plots, these are things we can use to measure how effective this model is working. So that's everything that I want for this one. I'm going to go ahead and click OK. And Excel will run the data. It'll run the analysis. And I see lots of output here. Well, you need to know how to interpret this output. Now, the first thing we're going to do is to go down here to where it says intercept and TV watching. And we may notice that those numbers correspond with the numbers in my model. At TV watching, that was my X explanatory variable. The number next to it is the slope. So there's the slope, and if I want it in a longer version, it's showing up here in the analysis. The intercept shown here in the analysis of the y-intercept that I see in my equation. I also notice that this r squared value is listed as r squared. So those are all values that we're familiar with from the equation. Now, other things that we want to see here, one of the things that we could look at is how this r squared is determined. And how that comes about is that it's a measure of error. So if my output, instead of using a model, if I just use the average of all of the GPAs as my output, I could use that as a predictor. I could just say, regardless of however many hours of TV you watch, your response is going to be the average GPA. That could be a predictor, but it's not a very good predictor. So there's a lot of error associated with that. And if I compared every point to the average, I'd get a ton of error. And the total of that error is shown here, the sum of the squares for all of the error. Now, by creating a model, I've reduced some of that error. I don't have as much error between each point and the model, the predicted value. And so I have reduced some of that, and that shows up here in this residual. And what I can do is I can then find the r squared by subtracting this residual from the total and find out how much error I've actually corrected using this model. So the way it works is we take equals and we start with 100%, that's everything. We're going to subtract a certain amount of the error, so this percentage. So I'm going to go ahead and take this residual error divided by the total error, and I'm going to hit enter, and we'll see that that is your r squared value. So it comes from the measures here, the sum of the squared error, which is under residual, and then the total error, which is the 1.34. Another thing that we can see, well, if I did want to find the r value, we don't necessarily see it here. It is actually going to be what is called multiple r here. But to find it, we would do the square root. So in Excel, that is SQRT, and I can take the square root of the number I just found here. And there's that 0.556603. That's the r value. And remember, r tells you direction and strength. So 0.556, it's a moderate strength. It's not going to tell you direction here. It's not going to give you the positive or negative. You're going to have to interpret that by looking at the line. Now, another thing to notice here is residuals. So what our model does is it predicts values. So for every possible number of hours of TV watched, our observations, 1, 2, 3, 4, and so forth, we can get our predicted GPA. So it's saying that for observation number 1, if I had 3 hours of TV watching, my predicted GPA would be 3.3. The actual was 3.5, so there's some error involved there, and the error is called the residual. See, these are these residuals. It's the actual distance from the point to the line, to the prediction. All of the predicted values show up on that line, but all of my original data are the points, and the difference between them is called a residual, or it's called the error. So we can actually get a plot of those residuals. We call it a residual plot, and we can see it here. And that residual plot basically just takes the line that we had and it flattens it out, and we can see it. And what we want to see here is just a random array of data. I don't want to see any patterns. I don't want to see it fanning out. Now this one actually has somewhat of a fanning pattern. So when you see a fanning pattern, that's the indication that perhaps an exponential model would work better. But when we just have a random assortment, then that's a pretty good indicator we have a good fit, or that at least a linear model is a decent fit rather than going to a different type of model. So we like to use a residual plot. There are different ways you can interpret them. If you see a curve, you know that a curved model would be better than a linear model. We like to use linear as much as we can because they're easier to interpret. So that gives you the basics of what you can see in Excel from the different values that are constructed for you. For the most part, we want to just focus on the slope and the intercept, and then these measures of how strong this model is.